Okay, so in this video we want to look at the remainder and factor theorems. The factor theorem really is just a special case of the remainder theorem. This is again a really important stepping stone to enable us to factorize polynomial equations, polynomial expressions, and then hence be able to solve polynomial equations. So we've looked at our division of polynomials, which is an important tool, together with the factor theorem that we'll introduce here. In the next video, we'll be able to put those two things together to enable us to factorize polynomials. Okay, so let's just start with an example, just to use as an illustrative to make a point. So we want to look at this polynomial, p of x. It's x cubed minus 4x squared plus 7x plus 10. And we want to find the remainder when x minus 2 is divided into p of x. Okay, so let's, in this case, do the division to find what remainder we end up with. So, good little recap of our long division. Okay, so I'm dividing x minus 2 into the cubic. The first thing I do is how many times does x go into x cubed, or what do I have to multiply x by to get x cubed? And that is x squared. That's the first part of my quotient that goes up the top. And then I multiply that quotient x squared by x minus 2, which gives me x cubed minus 2x squared. And then I subtract. Negative 4x squared, take away 2x squared. Negative 4 minus minus 2 is negative 4 plus 2. So that's negative 2x squared. And then we bring down the next term in our polynomial and we repeat the process. What do I have to multiply x by to get negative 2x squared? It's negative 2x. I multiply negative 2x by x minus 2, negative 2x squared plus 4x. And I subtract. 7x minus 4x is 3x. Bring down our next term and we're nearly done. What do I have to multiply x by to get 3x? It'll be plus 3. I take that 3 and I multiply it by x minus 2 to get 3x minus 6, and I subtract. 10 minus minus 6 is 10 plus 6, which is 16. Okay, and so therefore we find that the remainder is 16. The second part of this question asks us to find p of 2, which means we substitute 2 into our polynomial. So 2 cubed minus 4 times 2 squared plus 7 times 2 plus 10. 2 cubed is 8. 2 squared is 4 times 4 is 16. 7 times 2 is, 14. And then plus 10. So 8 minus 16 is negative 8. Or again, perhaps easier to do it by adding the positive things. 14 plus 10 is 24. Plus 8 is 32, take away 16 is 16. Okay, so what we found here was that p of 2 equals 16, which was the remainder. So we divided by x minus 2, p of 2. Now this is no coincidence, and let's have a look at this by thinking a bit more in terms of our equating coefficients definition before we have a look at the general reason as to why this works. Okay, so what we actually did there, let me write that down. We did our polynomial, I won't write it all out. We divided it by x minus 2, and we know that that's going to give us some kind of quadratic, ax squared plus bx plus c, or some kind of, it might not be quadratic if p is not a cubic, so some sort of quotient, let's call it q of x. It'll be quadratic. If p is a cubic, it'll be quadratic. If p was quartic, it'll be cubic, whatever it might be, plus our remainder over our divisor. Okay, that's generally what happens. Now, we've done this before. If we multiply everything in this equation by x minus 2, we get p of x equals x minus 2 times q of x plus r. So now, if we were to, so in this case what we did is we worked out p of 2. And we found that p of 2 ended up giving us the remainder. And the reason it ends up giving us the remainder is because in this bracket here, you're going to get 2 minus 2. And this bracket now becomes 0. And so actually you're finding that p of 2 gives you 0 times q of x plus r, and so it just gives you r. So p of 2 gives you the remainder. Now the reason it's 2 is because 2 is the value that makes x minus 2 equal 0. Okay, so if we were dividing by x minus 4, for example, then P of 2 wouldn't give us the remainder. It would need to be, what value can I sub in here to make it 0? So it'd need to be 4. So P of 4 would give the remainder. Okay. If it was x plus 5 that we were dividing by, okay, then this would be plus 5 here, and the question would be, okay, well, I'm going to be able to get the remainder if I can make this bracket 0. So that would have to be negative 5. So subbing negative 5 into my polynomial would give me the remainder. Okay. So generally speaking, when a polynomial is divided by x minus k, P of k gives the remainder. And that's because this is what's happening that we've just talked about over here. Okay. If it was x plus k that we were dividing by, you'd need to sub negative k into your polynomial. Okay. So when a polynomial, and all you're doing is you're working out what value of x would make this whole thing equal 0. So if you're confused about it, x minus k equals 0, x equals k, that's the value I sub into my polynomial to work out what the remainder will be. The question might be, well, why would I need to know what the remainder is? But actually the remainder becomes important in deciding whether or not something is a factor, because we know something's a factor if it leaves no remainder. So that's where it becomes important. Here's a proof of that in a more general sense. So as we just talked about up there, we take our polynomial, we divide it by x minus k. We know it gives us a quotient, q of x, plus a remainder divided by x minus k. If we multiply everything by x minus k, we get this relationship here. And then we know that we can find the remainder by substituting in something that will make this bracket equal to 0. So if we sub in k, P of k, we'll have k minus k here. That whole bracket will be 0, so that whole thing will disappear and it will equal r. Okay. Alright, we can also extend the remainder theorem to dividing P of x by a general linear factor, so it's the same logic. Okay, it's about you're subbing in the value that would make ax plus b equal to 0. So if we need ax plus b to equal 0, that means ax has to equal negative b, and so x has to equal negative b on a. So if that's the value we sub into our polynomial, that will make this bracket part here 0, and hence it will leave us just with the remainder. So when a polynomial is divided by x minus k, the remainder is found by evaluating P of k. When a polynomial is divided by ax plus b, its remainder is found by evaluating P of negative b on a. We work this out by working out what value of x would make that factor equal to 0. Okay. Use the remainder theorem to find the value of the remainder when P of x is that cubic and when that cubic is divided by 2x plus 1. Okay, so 2x plus 1 would equal 0 when x is equal to negative a half. Okay, so the remainder is going to be P of negative half. So we're going to substitute negative half into the polynomial. Negative half cubed minus 3 times negative half squared minus 6 times negative half plus 9. Okay, I'm just going to move that up because we're going to be a bit tight for space, I think. Okay, so negative half cubed is 2 times, it'll still be negative, it'll be 1/8. And then this is minus 3 times negative half squared will be positive a quarter. And it'll be plus 6, so it'll be this negative times negative, so it'll be positive. 6 times a half is 3, and plus 9. Okay, so we've got 2 times negative 1/8, which is negative 1/4, and then we've got minus 3/4, and then we've got plus 3 and plus 9. Negative a quarter minus 3/4 is negative 1, plus 3 plus 9 is positive 12, and negative 1 plus 12 is 11. So the remainder would be 11. Okay, these next two examples are other examples where we are forced to need to understand and use the remainder and factor theorems. If you've got a question like this, example 2, which is just find the remainder, you could just as easily find the remainder by doing the long division. It's up to you as to which is more efficient. However, this question, example 2, specified use the remainder theorem to find the remainder. But the point is that unless it said that, there are other ways for us to find the remainder. But you need to know the remainder theorem, because questions like these are quite common. So when P of x equals x cubed minus ax plus 5 is divided by x plus 2, the remainder is 9. Find the value of a. Okay, so we know that when we divide p of x by x plus 2, we know the remainder will be given by p of negative 2. Okay? X plus 2 equals 0 implies that x equals negative 2. That's what we're going to substitute into our polynomial to get the remainder. But we know, in this case, that the remainder is 9. So this information tells us that p of negative 2 equals 9. So we work out what p of negative 2 is. Negative 2 all cubed minus a times negative 2 plus 5, and that has to equal 9. And there we have an equation that we can solve for a. So negative 2 all cubed is negative 8. Negative a times negative 2 is positive 2a, plus 5 equals 9. Negative 8 plus 5, so that's 2a minus 3 equals 9. So 2a equals 12. And so a must be 6 if we get a remainder of 9 when we divide by x plus 2. Alright, another example like that. X cubed plus ax squared plus bx plus 3 has a remainder of 1 when divided by x plus 1, and a remainder of 11 when divided by x minus 1. Find the values of a and b. Okay, so if when we get a remainder of 1 when we divide by x plus 1, when we divide by x plus 1, the remainder is given by p of negative 1, and we know that remainder will be 1. Okay, so that's the information that we get from that. The second sentence, we get a remainder of 11, or the second part of the sentence, when we divide by x minus 1. When we divide by x minus 1, the remainder is given by p of 1. That would be the value of x that would make that 0. And we know that that remainder has to be 11. So those are the two bits of information that the question tells us. That is, they are going to allow us to form two equations, which will have two unknowns, a and b, and we can solve them simultaneously to find a and b. So p of negative 1, negative 1 cubed is negative 1, plus a times negative 1 squared, so it's just a times 1, minus b, and plus 3 equals 1. So let's just tidy this one up. That's a minus b plus 2 equals 1. So it's a minus b equals negative 1. There's equation 1. And then equation 2, we sub 1 into the polynomial. That's 1 plus a plus b plus 3. That has to equal 11. So we get a plus b plus 4 is 11. So a plus b is 7. There's equation 2. I've got two equations in a and b. I could subtract those two equations to eliminate a. I could add those two equations to eliminate b. Or I could make a the subject in equation 1 and sub it into equation 2. Whatever method of simultaneous equation solving you prefer to use, that's up to you. I'm going to do equation 1 plus equation 2 to eliminate b. So it'll be a plus a, which is 2a, negative b plus b, b is eliminated, negative 1 plus 7 is 6. So we get a equals 3, and then we're going to substitute a into whichever one we prefer. I'm going to go into equation 2 maybe. So 3 plus b equals 7, which means that b equals 4. Okay. If you need further practice solving simultaneous equations, go back to some of the earlier videos from the linear algebra at the start of the year and do a bit of revision there. It's very much an assumed skill at this point. Okay, the factor theorem. So all this is an extension of the remainder theorem, and it's essential to us being able to factorize, which we'll look at in the next videos. So we know that if something is a factor of something else, so if a is a factor of b, a divides exactly into b, leaving no remainder. So the whole idea of something will be a factor if there is a remainder of 0. Okay, so we already know from our remainder theorem that if we're dividing by x minus k, p of k is the remainder. So if p of k is equal to 0, then that means that x minus k has to be a factor. Okay. Similarly, same for the more complicated factors. If we're dividing by ax plus b, we find the remainder by evaluating p of negative b on a. And so therefore, if p of negative b on a equals 0, that means the remainder is 0, and it therefore means that ax plus b must be a factor. Okay, let's have a look at a couple of examples here. Show that x plus 1 is a factor of x cubed minus 2x squared minus 13x minus 10, and hence find the other linear factors. Okay, so I'm going to use my factor theorem. So I'm going to work out p of negative 1. That would be the value that would make x plus 1 equal to 0. So that gives me negative 1 cubed minus 2 times negative 1 squared minus 13 times negative 1 minus 10. So that's negative 1 minus 2 plus 13 and minus 10. So if we add up all those negatives, negative 1 minus 2 is minus 3, take away 10, you've got negative 13 plus 13, which equals 0. Okay, and so, sorry. And so therefore, we need to draw a conclusion from that. It's not up to the person marking your work to know what that means. Therefore, since p of negative 1 equals 0, x plus 1 is a factor of p of x. Okay, then the second part of the question asks us to hence find the other linear factors. So if we know one factor, so let's go back to numbers. If you know that 3 is a factor of 24 and you want to find another factor, you're going to divide 3 into 24 to learn that 8 is also a factor. Okay, so if I know that x plus 1 is a factor of p of x, I'm going to divide x plus 1 into p of x to find the other factor or other factors. X cubed minus 2x squared minus 13x minus 10. Okay, hopefully we're getting good at this long division by now. What do I multiply x by to get x cubed? That's x squared. X squared times x plus 1 is x cubed plus x squared, and then I subtract. Negative 2x squared minus x squared is minus 3x squared. Bring down our next term. What do we need to multiply x by to get negative 3x squared? Be minus 3x. Negative 3x times x plus 1 is negative 3x squared minus 3x. And then we subtract, Negative 13 minus 3 is negative 13 plus 3, so that's negative 10x. And then we bring down our next term. What would we have to multiply x by to get negative 10x? That'll be negative 10. Multiplying negative 10 by x plus 1 is negative 10x minus 10, and so that confirms we get a remainder of 0. But now what we've learnt is that p of x, our polynomial, is x plus 1 times x squared minus 3x minus 10. Or we learnt that p of x divided by x plus 1 is x squared minus 3x minus 10, and so that tells us that those two things, it's the same thing. If you learn that 24 divided by 3 is 8, that tells you that 24 is 3 times 8. Okay, it's the same information written in a different order. And then we want the other linear factors. So we've got one linear factor and one quadratic factor. So we know how to factorize quadratics though, so we want to further factorize that quadratic. So we've got the other linear factors. So factors of negative 10 that add up to negative 3 is x minus 5 and x plus 2. So therefore, the other linear factors, are x plus, oh no, we've already got x plus 1, x minus 5 and x plus 2. So it's also worth noting that given that the cubic has 3 linear factors, we would also have found if we'd subbed 5 into our polynomial, that would equal 0. There's no remainder when we divide by x minus 5. Also, if we sub negative 2 in, that would equal 0. There's no remainder when we divide by x plus 2. So when we come to trying to find a factor, which is what we'll need to do down the track, there's always 3 different answers that it's a trial and error process, but there's 3 different answers that you could stumble upon. So it's a fairly limited trial and error process, but we'll talk about that in the next video. Okay, final example here. Let's just do one more example where we've got some unknown coefficients. Find the values of a and b that make 2x cubed plus ax minus 13, sorry, that should be ax squared. My apologies, just fix that. Plus ax squared minus 13x plus b exactly divisible by x squared minus x minus 6. Okay, so our factor theorem and our remainder theorem is all about linear factors, and this is not a linear factor, this is a quadratic factor, okay? But it's a bit like, if I know that something is divisible by 12, then I know it's also divisible by 4 and 3, it's also divisible by 2 and 6, okay? So if I know that something is divisible by x squared minus x minus 6, well, factorising that, factors of negative 6 that add up to negative 1, it's this. So if it's divisible by the quadratic, that means it is divisible by both of these linear expressions, okay? So we know that p of x is divisible by x minus 3, which means that p of 3 will equal 0. There's no remainder when we divide by x minus 3. And we also know that p of x is divisible by x plus 2, which means that p of negative 2 also equals 0. So we're going to use these two bits of information to form two equations with a and b that we can solve simultaneously to find a and b. Alright, so p of 3 equals 0. Subbing 3 into that polynomial, 2 times 3 cubed plus a times 3 squared plus, minus 13 times 3 plus b, and that has to equal 0. So 3 cubed is 27, 2 times 27 is 54, 3 squared is 9, so it's 9a, 13 times 3 is 39, and plus b equals 0. Okay, so 54 minus 39 is going to be 15. Yep. So 9a plus b plus 15 equals 0, or 9a plus b equals negative 15. Let's call that equation 1. And then my other equation is going to come from p of negative 2 equals 0. So 2 times negative 2 cubed plus a times negative 2 squared minus 13 times negative 2 plus b equals 0. Okay, so negative 2 cubed is negative 8, times 2 is negative 16, negative 2 squared is positive 4, negative 13 times negative 2 is positive 26, and plus b equals 0. So we've got 4a plus b, negative 16 plus 26 is 10, and so 4a plus b equals negative 10, equation 2. Okay, so these are our two equations that we're going to solve simultaneously. Easiest to eliminate b or to make b the subject in one of them and use substitution. I'm going to eliminate b, and I'm going to do that by doing equation 1 take away equation 2. So 9a minus 4a is 5a. b minus b eliminates b, that was the point. Negative 15 minus minus 10 is negative 15 plus 10, which is negative 5. And so a is negative 1, and then we're going to substitute a into, I'll just go into equation 2, and so we know that's going to be negative 4 plus b equals negative 10, and so b is negative 10 plus 4, which is negative 6. So a is negative 1 and b is negative 6. Okay, so there is a mixture of questions from exercise 6C and also a short worksheet with just, I think, 4 or 5 questions in addition to that on the remainder and factor theorems.